I'm going to start the next chapter, and that chapter is what is motion in a straight line. I hope maybe many of the topic of this chapter already have studied in the class ninth here. Huh? And only a quick revision of that or the some more topic or some more extra thing is given in this chapter. Otherwise, the rest thing which already have studied in the class ninth here. So before I start this motion in a straight line, first here I want to tell you what is the frame of reference and what is the inertial and non-inertial reference frame. So first thing here, what is the reference of frame? So some physical phenomena or events can be specified by proper position and time coordinate. कहां से कब और कहां, जैसे कोई भी इवेंट होती है तो हम ये दो चीजें पूछते हैं कि कब हुई और कहां हुई. It means the physical phenomena or the events is always described with respect to some position and time. And to describe any event or phenomena, the coordinate means position and time coordinate which is required. That one is called its frame of reference. And frame of reference is always two types. One is inertial frame of reference and other is non-inertial. As it is clear, inertial reference frame is that reference frame or that frame of reference in which the Newton's first law is completely described. And the such type of reference frame is non-accelerating and non-rotating. While a reference frame which is accelerated and rotated, or which one is accelerating and rotating, that one is called here non-inertial reference frame. मैंने क्या बताया, non accelerating और non rotating ये आएगा inertial reference frame, और accelerating and rotating that one is called non-inertial reference frame. So the example of the non-inertial reference frame means simply you can say any reference frame which is attached to any aircraft that is making take off. टेक ऑफ मतलब वहां पे क्या होगा, एक्सेलरेटेड हो जाएगा. या नॉन इनर्शियल रेफरेंस फ्रेम का एग्जांपल जैसे ए रोटेटिंग मैरी गो राउंड, तो दैट वन इज आल्सो व्हाट हियर example of the non-inertial reference frame. So later I will tell you more about this one, what is the inertial and non-inertial reference frame here. Now we will come on the topic motion and rest. Motion and rest. As it is clear, all of you know about this one, how can we define the motion and rest? Motion means a body is said to be in motion when its position is changes with respect to time. अगर किसी बॉडी की पोजीशन टाइम के साथ अगर बदल रही है तो that body is said to be in motion. And if the position of the body does not change with respect to time, it means that body is said to be in rest. Simply you can say here, keep motion and rest defined on the basis of the position of the body, either that position is changes with time or not. Now the position of an object in space can be specified or can be with the help of the three axes, as you know, x-axis, y-axis and z-axis. So when a body contains all these three axes in its motion, so that body is said to be in motion in three dimensions. So generally out of these three axes, x-axis, y-axis and z-axis, when we consider the change in the position of the object with respect to time only along one axis, आउट ऑफ दीज थ्री, इन तीनों एक्सिस में से जब हम किसी बॉडी के मोशन को कंसीडर करते हैं ओनली अलोंग वन एक्सिस, तो उसको कहते हैं मोशन इन वन डायमेंशन. जैसे मोशन ऑफ ए कार ऑन ए रोड, और मोशन ऑफ ए ट्रेन ऑन ए रेलवे ट्रैक, और मोशन अंडर ग्रेविटी. तो इस समय क्या है, we are considering the motion only in one dimension, means only one axis. Out of these three axes x, y and z, only one axis is involved for its motion, so that motion is said to be motion in one dimension. But if the position of the object is changes with respect to time is considered the two axis, means out of these three axes, if any two axes is involved in the motion of any object, then that object is said to be motion in two dimension. For example, the motion of a planet around the sun, that one is considered what here? Motion in two dimension. Or the motion of a body in a circle, or an insect is crawling on the floor, all these consider what here? Motion in two dimension. And what is motion in three dimension? When the position of the body is specified with respect to time by considering all the three axes, x-axis, y-axis and z-axis, then that motion is said to be motion in three dimension. For example, motion of a gaseous molecule contained in any cylinder. जैसे कहीं भी अगर किसी बॉक्स में कोई गैस अगर कंटेन की गई है तो उसके मॉलिक्यूल्स का जो मोशन होता है, दैट मोशन इज सेड टू बी मोशन इन three dimension. So in this way we can discuss the motion of a body either in one dimension or two dimension or three dimension here. So here our aim is to what here? Motion in a straight line. So a straight line means out of these three axes here I am taking only one axis, either x axis or y axis or z axis. So actually here we are going to discuss about the motion in one dimension. Now, some definition related to motion here. And first one is distance and displacement. I hope maybe all of you know what is the distance and displacement. Distance is what? Distance is the actual length in a time interval between initial and final point. मतलब कि किसी टाइम इंटरवल में जो इनिशियल और फाइनल पॉइंट के बीच में जो भी डिस्टेंस होती है, जो भी लेंथ होती है, उसको हम क्या करते हैं? डिस्टेंस. और सिंपली यू कैन से द लेंथ ऑफ एक्चुअल पाथ इन ए टाइम इंटरवल इज कॉल्ड द डिस्टेंस. व्हाइल व्हाट इज द डिस्प्लेसमेंट? डिस्प्लेसमेंट इज द difference of length, or simply you can say shortest distance between initial and final point. So simply you can say here the difference between initial and final point of any object in a time interval is called what here? Displacement. So simply, or in other words, you can say displacement is the shortest distance between initial and final point. And as you know, distance is a scalar quantity, displacement vector quantity. So I hope maybe all of you know all these things here. What is the distance and what is the displacement? You know, since distance is a scalar quantity, तो magnitude of this one will be never comes to zero. जैसे हम कहें कि हम यहाँ से लेकर के इस वॉल से इस वॉल तक जाएं और मान लीजिए इनके बीच की डिस्टेंस है 5 मीटर. तो when we return back at the same wall, so distance becomes 10 meter. While the displacement becomes zero. So as you know here, displacement is the difference between the final and initial position of the object. So one is final and initial position का जो difference होगा वो हो गया displacement, और जो actual length है वो क्या कहलाती है in a time interval? वो कहलाता है distance. Next one is speed. As you know, speed is what here? The distance traveled by the body per unit time, or in unit interval of time, the distance traveled by a body is called the speed. And you can write here, speed is equal to distance upon time. And if the body covers equal distance in equal interval of time, it means that body is moving with a uniform speed. अगर बॉडी इक्वल डिस्टेंस ट्रेवल कर रही है इक्वल इंटरवल ऑफ टाइम में, तो आप कर सकते हैं उस बॉडी की स्पीड क्या है? यूनिफॉर्म स्पीड है. और एक होता है एवरेज स्पीड. तो एवरेज स्पीड क्या होती है? एवरेज स्पीड इज इक्वल टू टोटल डिस्टेंस अपॉन टोटल टाइम. और एक होता है इंस्टेंटेनियस स्पीड. इंस्टेंटेनियस स्पीड मीन्स द स्पीड ऑफ एनी बॉडी एट एनी पर्टिकुलर टाइम. जैसे गाड़ी का जो स्पीडोमीटर होता है वो क्या बताता है? आपको एवरेज स्पीड बताता है कि इंस्टेंटेनियस स्पीड बताता है? तो द स्पीडोमीटर ऑफ ए व्हीकल इज गिव्स द इंस्टेंटेनियस स्पीड. क्यों? क्योंकि किसी पर्टिकुलर टाइम पे आप देख सकते हैं कि आपकी स्पीड कितनी है. एंड एज यू नो, स्पीड इज ए scalar quantity. Its unit SI unit meter per second, and its dimension is what here, LT to the power minus. Next definition is velocity. I hope maybe also you are familiar with this term. Velocity is what here? The average, simply because the displacement of an object in unit interval of time. वहां पे हमने लिया था स्पीड के लिए द डिस्टेंस, और यहाँ पे क्या लेंगे, डिस्प्लेसमेंट. तो सिंपली यू कैन से हियर velocity is defined as the displacement of an object in a unit interval of time, and velocity is equal to, you can write, displacement upon time interval. Suppose with a body is moving in a straight line. मान लीजिए कोई बॉडी एक स्ट्रेट लाइन में मूव कर रही है, एंड विथ रिस्पेक्ट टू एनी रेफरेंस पॉइंट, मान लेते हैं ओ इसका रेफरेंस पॉइंट है. ओ रेफरेंस पॉइंट मतलब जहां से स्टार्ट हुआ बॉडी चलना. एंड सपोज इन टाइम t1 द बॉडी कवर्स ए डिस्टेंस s1, एंड इन टाइम t2 इट्स पोजीशन बिकम्स s2. मान लो कोई बॉडी है स्ट्रेट लाइन में मूव कर रही है, किसी टाइम इंटरवल t1 में उसका डिस्प्लेसमेंट s1 था, और टाइम t2 में वो कितना हो गया डिस्प्लेसमेंट s2. इट मींस इन टाइम इंटरवल t2 minus t1 what is the displacement of this body, s2 minus s1. So if anybody asks to you कि what is the average velocity in this one, so we can write average velocity which is also written as v here, bar means average, is equal to s2 minus s1, means displacement s2 minus s1 upon, in what interval of time this displacement, t2 minus t1. Hence the average velocity which you can write here, v bar is equal to s2 minus s1 upon t2 minus t1, and the difference of the two quantity, for the difference you can write delta. Delta represents the difference. तो at place of s2 minus s1 you can write delta. डेल्टा क्या बताता है, दो चीजों का डिफरेंस. आप किसका डिफरेंस लिए हैं, डिस्प्लेसमेंट का. तो वी कैन राइट हियर डेल्टा s, और ये टाइम का डिफरेंस ले सकते हैं डेल्टा t. इट मींस द एवरेज वेलोसिटी v bar is equal to delta s upon delta t. And remember this, when this delta t becomes very small, or when delta t tends to zero means when this time delta t is very small, then this average velocity becomes instantaneous velocity. Instantaneous velocity v, हमने क्या कहा, अगर इस डेल्टा टी को बहुत छोटा कर दिया जाए, बहुत छोटा करने का मतलब when delta t tends to zero means approaches to zero but not equal to zero. तो when instantaneous velocity v is equal to, इसको हम लिख सकते हैं लिमिट डेल्टा t tends to zero. अगर हम यहाँ पे इस डेल्टा t को बहुत छोटा कर दें tends to zero, डेल्टा s अपॉन डेल्टा t, तो ये पूरा टर्म कहलाता है इंस्टेंटेनियस वेलोसिटी. और उस इंस्टेंटेनियस वेलोसिटी को हम ds अपॉन dt भी लिखते हैं. तो ये हो जाएगी एवरेज वेलोसिटी, और ये हो जाएगा इंस्टेंटेनियस वेलोसिटी. अगर कोई भी फिजिकल क्वांटिटी आप एवरेज जानते हो, जैसे हम कहें एवरेज एक्सीलरेशन, तो एवरेज एक्सीलरेशन से हमको इंस्टेंटेनियस एक्सीलरेशन निकालने के लिए क्या करेंगे, डेल्टा t टेंड्स टू जीरो. तो जहां पे डेल्टा t टेंड्स टू जीरो लेंगे तो हमको तुरंत वहां क्या मिल जाएगा, इंस्टेंटेनियस वैल्यू ऑफ दैट क्वांटिटी. And also, you know, speed is a scalar quantity, velocity vector quantity, and second thing, the unit SI unit of both is meter per second, and dimension, as you know, LT to the power minus 1. So since all this term is not new for you, already have studied all these terms in the class 9th, so today you go through this one here. In the next video, again I will give you what is the acceleration, average acceleration, instantaneous acceleration, and then how can you find the actual velocity, or simply you can say acceleration by the displacement time graph, velocity time graph. So in the next video I will discuss the different types of the graphs.